In this question, we have a proton in a magnetic field, and the proton is going to go in a circular path, something like this. Okay, so I sort of have like a bit of a side view, a little bit up, but generally a side view of the proton as it goes around and around and around in a circular path in this direction. And what we're going to do is we're going to try to find out what is the frequency of its path as it goes around and around and around. Now, of course, magnetic fields make charges go in a circular pattern. So we're going to find out the frequency of it going around, as well as what is the direction of the magnetic field that actually exists in the situation. Now, I know there's two forces involved in this scenario. I've got a magnetic force, because we have a charge moving in a magnetic field, and I've also got, since it's moving in a circle, there must also be centripetal force, and the two are equal because it's the magnetic force that caused it to move in a circle in the first place. So I put those two things together. I've got QVB sine theta for magnetic force is going to be equal to mv squared over r for centripetal force, and the sine theta is going to be equal to 1, so we don't have to worry about it. Now, one of the v's cancels off, which is kind of convenient, and then if we rearrange, we can solve for the v, which is the only thing I don't have, and I need to find my frequency with it. So if I rearrange this, I can calculate the speed of my particle as being qbr divided by mass. Now, I know the charge of the proton, I know the mass of the proton, I know the magnetic field, as well as the radius of the path. So I put those in there. My proton is moving at approximately 1,070 meters per second. Once I have that speed, I can use that speed to find out my frequency using the classic expression from circular motion. Frequency is speed divided by 2 pi r, which is basically the inverse of the dTV expression. And we can find out that the proton's whipping around with a frequency of about 3,960 hertz. Now, for the direction of the magnetic field, I need to use my right-hand rule to figure it out. I've got the force on the proton is going towards the center of the circle. The proton is moving sideways, so I can't use an in and out type vector. The in and out vector would be the centripetal force, so it actually would be represented by an x. The velocity is going towards the sideways, it's going towards the left. So that means that my magnetic field has to be going up or down. And if I use my right-hand rule, I can see that my magnetic field would have to be going up in this circumstance. So the magnetic field would be coming up like this, nice vertical field, and the magnetic field is causing the proton to then go in a nice circular path.